Topic: Advances in bioproduction of polylactic acid and its precursors. Introduction. Lactic acid is one of the most important building block chemicals in the world. It contains hydroxyl group and a carboxyl group. Because of its functional groups, lactic acid could be used as a starting material for the synthesis of various chemicals such as acrylic acid, propanediol, pentanedione. The most widely applied use for a lactic acid is in the production of biodegradable polymers. Polylactic acid. Polylactic acid is a biodegradable polymer which has recently increased in global demand due to its increasing application such as a bioplastic. Global plastics production totaled 368 million metric tons in 2020. At an estimated 10% of fossil fuel based plastics, the overall demand for a polylactic acid is envisioned to reach 30 million tons per year. As a precursor of polylactic acid, the demand for a lactic acid is estimated to reach 1960 kilotons 2025. Objectives: to optimize the utilization rate of substrates and improve the industrial adaptability of strains through the biological engineering, to produce a polylactic acid and use an environment-friendly material, to work with polylactic acid and energy to transform. Polylactic acid melts more easily because it has a lower melting point than many fossil-based plastics. Plan. Creating polylactic acid is ring-opening polymerization of lactide with various metal catalysts, either in a solution or as a suspension. The metal catalyzed reaction tends to lead a raceminization of the polylactic acid, which reduces stereoregularity when compared to the biomass starting material. Made from a recyclable and renewable, polylactic acid has a lot of positives for the futures. Plus, the rising oil price, a corn-based plastic has financial benefits too. For all of these positives, the low melting point of polylactic acid compared to plastic like a PET means that it has picked up for as many applications as of yet. The cost of polylactic acid production has also reduced over the decades, but care needs to be taken to decompose this material, which needs special compositing in facilities that can heat the material 140 degrees Celsius for 10 days. Summary: lactic acid is a versatile green platform compound. Lactic acid and its derivatives have been widely used in food, medicine, environmental protection, biodegradable polymer production, and other industrial fields. Demand for lactic acid and its derivatives is increasing. With the increasing cost of glucose and other raw materials, the production cost of lactic acid is also increasing, which has seriously affected the profit margin of the lactic acid industry. The economical analysis showed that the concentration of lactic acid should be higher than 180 gram per liter, and the conversion rates could be exceed 95% at an industrial scale in the future. At present, the reported strains showed low utilization efficiency of raw materials. It is necessary to optimize the utilization rate of substrates and improve the industrial adaptability of strains through the biological engineering. Furthermore, the development for a extremophilic lactic acid procedure, including thermophiles, pseudophiles, and alkaphiles, can be minimize contamination problems during processing. This will be a direction for a low-cost lactic acid fermentation. Polylactic acid has recently received much more attention and interest for its potential applications in biomedicine and plastic pollution and fossil fuel depletion are among the world's most pressing issues. The most important factors to consider are likely to be resource sustainability, global warming, and environmental damage caused by plastic waste. Renewable and biodegradable derived from a fermentative uh, lactic acid can replace petroleum-based plastics. Polylactic acid and its derivatives have been extensively used in therapeutic applications such as cancer therapy, drug delivery, and encapsulation and protection, environmental protection. Acknowledgements. Conceptualization done by Asodhari Ankit, research done by Chovatia Hiren, storyboard done by Malek Salman, design and editing done by Patel Jhil, and narration is done by Shah